Howdy, welcome back. So this is the second review video for Exam 1. If you have not watched the first review video, go ahead and stop this video and watch that one first. So as a just quick recap, in the first video we ran two regressions. First, this simple multivariate linear regression with a dummy variable, and then a second multivariate linear regression with a dummy variable, but this one has more than two categories. So we talked about the necessity of having to drop one of those dummy variables and have that be the base case. So again, watch that video if you haven't already. So now we're going to move into an interaction model with a dummy variable. So what do we mean by that? Again, we have this model here where soda expenditures are a function of gender. Gender is a dummy variable equal to 1 if person I is a female, equal to 0 if person I is a male. Spending is also a function of income, and then the interaction between gender and income. So what this model does, and you can see more information about this in the actual lecture material, is beta 1 is going to capture the difference in spending between the genders on average. So this beta 1 is going to tell us, on average, do women spend more or less than men on soda expenditures? And then this beta 3, if we look at the partial effect of income, it's going to be different for men and women. So again, just as a recap, again, this is also more detail in the lecture material. But for women, whose gender equals 1 in this case, this original model here is going to look a little different. So beta 1 is just by itself because gender is equal to 1. So that's beta 1 times 1. We just have beta 1. And then over here, gender is equal to 1. 1 times income is just income. Times beta 3 is going to be beta 3 times income. Okay. So for women, this top model here looks like this. We can group things together and factor out income, and what we end up getting is this. So for women, soda expenditures is a function of this intercept term here, which is beta naught plus beta 1, and then this slope here, which is beta 2 plus beta 3 times income. For men, the gender is equal to 0, meaning that this beta 1 here is going to disappear. This whole term disappears, and 0 times income is 0, times beta 3 is still 0. So this is also going to disappear. So for men, this first equation up here looks like just beta naught plus beta 2 times income. Okay, so the difference on average in spending between men and women is going to be captured by beta 1. And then the partial effect of income on spending is going to be different for men and women, right? So the partial effect of income on spending for men is going to be just beta 2. And the partial effect of income on spending for women is going to be beta 2 plus beta 3. Meaning that beta 3 is going to be the difference in the partial effect of income on spending between men and women. Okay, so let's go ahead and just run this model and see what we're talking about here, okay? So in Excel, pull up the review Excel document. Again, that's found on eCampus. We're starting with a fresh version here. And so what we want to do is run this regression, right? So spending is a function of gender, income, and then the interaction between those two. So we have gender here, we have income here, but first of all, they're not next to each other. They need to be next to each other when we run this regression. And then secondly, we need to create this new variable, which is the interaction between income and gender. Okay, so again, a lot of ways to organize this and rearrange it. Do whatever you'd like to. What I'm going to do is select this entire column C, hit the insert button twice, and then I'm going to move the income variable over to column C, and then in column D, I'm going to create this interaction term. So I'm going to say gender, I'll say gen multiplied by income. Okay, and that variable is going to be equal to gender times income for every individual. So I'll wait here for a second, pause the video here, make sure you have the right formula. Okay, so we're going to hit enter, and then copy that same formula for the rest of the observations. Okay, so now we have all three variables, and all three explanatory variables, and we have the dependent variable out here. Okay, so we're ready to run the regression. So we go to the Data tab up top, Data Analysis, hit Regression, hit OK. For our Y range, we're going to select SOTA expenditures, including this first row of labels. For the X range, we're going to select gender and income, and then the interaction between gender and income. Okay, all three of those columns. Hit the labels option, and I'm going to send this regression output to a new worksheet, and I'm going to call it dummy variable with interaction. Okay, hit OK, and there we go. We have our regression output. So we'll zoom in here. So we go through the same process with all the regression outputs. So this is multivariate regression. So we're looking at the adjusted R-squared. This is 0.44, meaning that gender, income, and the interaction between gender and income explain about 44% of the variation in SOTA expenditures. Okay, not bad. The F-stat here is very small, 6.86 times 10 to the negative fifth, meaning we reject the null on the F test, meaning that our model is jointly significant, or at least one of these three coefficients here is significant. Okay, great. Now we look at the actual coefficients. We look at the p-value, so these are little t-tests for every single coefficient. This first one here, the intercept term, is significant. The second one here is significant at the 10% level, but if our alpha is 0.05, this is insignificant. Okay. This coefficient on income is significant, and the interaction between the two, gender and income, is insignificant. So we have our actual output here, but if we were to, I'm going to copy and paste the results here. The intercept here, we just said is significant, so we're going to keep it as it is. The coefficient on gender, we said is insignificant if our alpha is 0.05, so we're going to consider this to be 0. Income, the coefficient here, we said is significant, so we're going to keep it as is. And the interaction between gender and income here, we said is insignificant, so we're going to consider that to be 0. Okay, so even though our results give us these four coefficients, based on the p-value or the t-stat or the confidence interval, we're actually going to consider the results to be these four numbers here. Okay, what does this mean? Well, the dummy variable on gender is 0, meaning that there is no significant difference in spending between men and women, keeping income and the interaction between gender and income constant. Okay, no effect there. The partial effect of income on SOTA expenditures, very similar to what we had done in previous regressions, 0.002, meaning as income increases by $1, SOTA expenditures should increase by $0.002 or 0.2 cents, holding gender and the interaction between gender and income constant. And our beta 3 from our model is 0, meaning that there is no difference between men and women on the partial effect of income on gender. So income does positively affect SOTA expenditures, meaning as you get more income, you should spend more, even though it's a very small amount. And that's not different between men and women. Okay, so men and women are spending on average the same amount on SOTA expenditures, and getting an additional $1 for women does not have any other difference than getting an additional $1 for a man. So there's no difference in that partial effect across genders. Okay, so that's it. So we've estimated that model with a dummy variable and an interaction between a dummy variable and a normal quantitative variable.